Okay, Brent,
So,
go ahead.
okay. So right here we have a 5x5 LED cube that we have hooked to 4 shift registers, and to since there's 125 LEDs and we need to control each and every one of them separately, we use these shift registers to lower the amount of wires that need to come out of the Dragon 12. And so the Dragon 12 fills the shift registers with what bits we want or what LEDs we want. And then with the program we have, the multiplexing basically goes up the layers in a fast enough rate that we don't see that it changes. It's changing each one by one. It's turning off and on fast enough that it looks like they're all on. We did have a trouble with one layer in the back here that doesn't seem to be working. I can't get it to work. It's something with the soldering, I believe, the back connection. But we have the shift registers right here with 250 or 270 ohm resistors connected to each of these wires that are underneath this. That will each column is being basically powered. And then on the side here we have, I don't know if you can see, but these are the grounds. These red wires are the grounds that we use to go to the transistors. And when the transistors are powered on, the ground is basically on. So you can light up each layer basically. And if all the layers were running, it would be a lot of power, and it's not very efficient. And we wanted to see if we could make the multiplexing like we did in uh, the previous lab with the 7-segment display, which we was able to do. I'm not sure if you can see like the shimmer in it, but there's a shimmer in it from it going up and down
Yeah.
the the cube. Um, but yeah, there's these. Each one of them are 270 ohm resistors, and they're connected to each of the ports in for the columns of this. And then the rest of the wiring is basically just keeps it all it's in series. So it basically the clock of the Dragon 12 uh, and this are in sync, so it's not missing any bits when this is sending out bits to the shift registers. It has to be uh, they have to be that have the same clock. So that's why there's those wires coming out of it, and there's one hanging off. That's just to clear the shift register, and it's not really needed in this project. But you can basically clear all the bits if you want to. But with this part, it's basically just multiplexing each layer up, and we decided to test it out. We tried Conway's Game of Life, but uh, unfortunately, we weren't able to get it completely working. But yeah, so yeah, there's the shift registers, and then I don't know if you can tell, but each of these are the 25 columns, and then over here are the the grounds basically that are connected to transistors that turn the ground on and off. So basically connects or disconnects each ground. So not all the LEDs are on all at once. Um, but yeah, all that using just a few wires from the Dragon board.
So what you use in your code?
We use the code.
Yeah.
We use the loop.
Yeah.
We basically each time the iteration happened, uh, we changed these last bits right here one by one, changing it so each layer is a 1 and the rest of them are 0. So
Mm,
there's no, there's only at one time there's only one layer turning on,
mm,
and the rest of them right for now. I mean, you can control each of these to whatever you want, but right now they're all turned on to see basically if they all work. Which we do have one layer that doesn't work, or one column. I'm sorry,
mm,
one column that doesn't work. Um, but I get you can kind of see where we was going to do an 8x8, but due to time restraints, there's only a 5x5. But we in the code we used basically two words
mm,
that the bits were either for the columns or for the rows, and for the rows, only one. There's only one that could be one at a time, so it shifts to the right till it gets to the end, and then it goes back, and the rest of them are on. But the loop happens at such a fast pace that all of them turn on or look like they're on.
mm. Okay. Okay, very good. So one last thing, could you introduce yourself and your partner and the name of your project?
Yes, my name is Brent Hankins, and my partner is Jalen Joyce. Uh, I'm not sure if he has video on or not, but we did this project together,
What is the name of the
and
project?
yeah, we're part of Section 2.
What is the name of the project? Sorry.
The name of the project
Yeah.
is 3D lattice 3D LED lattice team is what
Okay.
we.
Okay, very good. Just 1 second.